Welcome. Today I will walk you through PyLine Giver, an end-to-end LLM observability and evaluation platform designed to give your organization complete visibility and control over your AI applications in production. PyLine Giver addresses three foundational challenges that every team deploying large LLM models faces: observability, understanding what your AI is doing at runtime; evaluation, measuring whether it's doing it well; and guardrails, ensuring it's doing it safely and within policy. Let's walk through each of these pillars in the platform. LangEval is a multi-tenant platform. Each team or product line operates within its own isolated project workspace with full role-based access control. Owners, admins, members, and viewers, ensuring that the right people have the right level of access. Authentication supports standard email and password credentials. Once authenticated, every view in the platform is automatically scoped to the selected project. All telemetry data, evaluation results, and configuration are isolated per project, critical for multi-team environments and data governance. This is the observability dashboard for research agent project, our real-time command center for understanding the operational health of this LLM application. The dashboard consolidates telemetry signals across 5 dimensions: trace throughput, observation depth, inference cost, evaluation quality, and user consumption. As you can see, there are multiple KPIs on this dashboard, like total number of traces, total model cost, scores, user consumption, by token cost, and also by the count of traces, traces by time, observation by level, model uses, also divided by 4 types like cost by model, cost by type, uses by model, and uses by type, and last, evaluation cost by template and by user. The traces module is the core of PyLine Giver's observability capability. It provides distributed tracing for LLM applications, a technique borrowed from microservices observability and adapted specially for AI pipelines and agentic workflows. A trace list is a paginated filterable view of all captured execution traces. Each row represents one complete LLM pipeline run, with columns for workflow name, status, end-to-end latency, and total inference cost. Filtering supports time range, execution status, and user identity. This makes incident investigation fast. If a user reports a degraded response, you can isolate the exact trace within seconds without digging through raw logs. Opening a trace reveals a span waterfall, a hierarchical timeline of every operation that executed within that pipeline. In LLM observability, a span is a discrete instrumented unit of work. In this trace, as you can see, several span types like the workflow, execute task, LLM call, custom span, tool call. Each span captures its start time, duration, and cost, giving you precise latency breakdown across every stage of your pipeline. This is how you identify where your latency is being spent, whether it's in retrieval, inference, or post-processing. When you click on a particular span, it shows everything about that span, like the input, output, latency, total tokens, and cost for that span. This level of granularity is essential for prompt debugging, regression analysis, and maintaining a complete audit trail of model interactions, a requirement in many regulated industries. The evaluation model is where PyLine Eval moves beyond basic observability into systematic LLM quality management. This is how you operationalize your definition of output quality and enforce it consistently at scale. PyLine Eval's evaluation system is built on two concepts: evaluation templates and evaluation configs. A template is a quality specification. It defines the evaluation prompt, the variable mapping between your trace data and the judge input, the scoring scale, and a passing threshold. A config activates a template against a specific scope of traces. You can target all traces from a particular service, a specific environment, or a specific span type. This allows fine-grained evaluation coverage across a complex multi-service architecture. PyLine Giver supports multiple evaluation methodologies natively: LLM-as-a-judge, where a frontier model acts as an automated grader; semantic similarity, which measures embedding space proximity between actual and expected output; glue and CHRF scoring for translation and text generation tasks; and readability and PII detection evaluators. The evaluation in PyLine Giver is divided into 3 sections. First one is agentic, non-agentic, and the last one is non-LLM evaluation. Here is the active LLM-as-a-judge template. The evaluation prompt instructs the judge model to assess a response or faithfulness. It takes question and answer as input. The variable mapping section defines how fields from the trace are injected into the judge prompt at evaluation. This decoupling of template from data means the same template can be reused across different trace schemas without modification. Each evaluation config has a lifecycle. It can be activated to begin evaluating incoming traces or deactivated to pause evaluation without deleting the configuration. Activation state along with who activated the config and when is tracked for governance and auditability. When a config is active, evaluation jobs are dispatched asynchronously to a dedicated evaluation worker queue after each trace ingestion, meaning evaluation runs continuously in the background with no impact on your application's response latency. The dataset module enables offline batch evaluation, a structured, reproducible approach to measuring model quality against a curated set of ground truth examples. This is a foundation of rigorous LLM regression testing workflow. A dataset in PyLine is a collection of input-output pairs with optional ground truth context. Dataset can be uploaded as a CSV or JSON and then mapped to the platform standard schema, typically an input field, an expected output field, and optional metadata columns. This dataset represents a curated golden set, a representative sample of real-world queries paired with verified correct answers, often assembled from production traffic or domain expert reviews. So here we can create a dataset. Here we have to map the columns to our standard schema and click on import. This is a result of running an LLM-as-a-judge evaluation against the entire dataset. Each row corresponds to one dataset item. The platform shows the evaluation score, pass-fail determination, and the judge reasoning for each item. Aggregate metrics at the top, overall pass rate, and mean score give you an immediate read on model performance against your golden dataset. This is the number you compare before and after a model upgrade, a prompt change, or a retrieval pipeline update. The Guardrails module provides real-time safety and policy enforcement for production AI services. Guardrails intercept model outputs before they reach end users, applying configurable detection and filtering rules to prevent policy violations. A guardrail policy is scoped to a service environment tuple. For example, your customer-facing chatbot in production environment. This allows different risk profiles and enforcement levels across different deployments. The policy supports two primary enforcement layers. The first is PII detection. It is configurable rules that scan model outputs for personally identifiable information such as names, email address, phone numbers, and financial data, preventing accidental data exfiltration through the AI layer. The second is LLM guard scanning, a suite of content safety classifiers that detect and filter harmful, off-topic, or policy-violating content before it's returned to the user. The fail mode determines the enforcement behavior, whether to block and return an error or to flag and pass through with an audit record. One of the key architecture advantages of PyLine Giver's guardrail system is real-time policy propagation. When you update a guardrail policy here, a change is immediately pushed to all connected SDK instances via a server-sent event stream. No application redeployment required, no restart, no downtime. Your AI application picks up the new policy within milliseconds. This is critical for responding to emerging risk or compliance requirements in production. Every guardrail policy change is captured in an immutable audit log, recording the actor, the timestamp, and the delta between previous and applied configuration, including the policy version number. This audit trail is essential for compliance reporting, incident post-mortems, and demonstrating AI governance control to regulators or enterprise risk team. The settings area covers the operational infrastructure of the platform, API key management, team access control, and LLM provider integrations. API keys are the authentication mechanism for the PyLine SDK and any external system sending telemetry to PyLine Giver. Keys are stored as a SHA-256 hashes. The plain text key is shown only once at creation and is never persisted, following security best practices. Keys can be revoked instantly, immediately blocking any further ingestion from the key without requiring application changes. Project membership is managed through a 4-tier RBAC model: owner, admin, member, and viewer. Each tier has a strictly enforced permission boundary. Viewers have read-only access to all data. Admins can manage configurations and evaluation workflows. Only owners can perform destructive actions like project deletion or member removal. This model supports least privilege access across the large engineering organization. LLM connection defines the model provider available to the evaluation engine. PyLine supports OpenAI, Anthropic, Azure OpenAI, Amazon Bedrock, and Google Vertex AI as evaluation backends. Credentials are encrypted at rest using AES encryption, with key managed through HashiCorp Vault, industry standard secret management. Credentials are never returned in plain text after storage. The UI masks them on all subsequent views. To summarize, PyLine addresses the full life cycle of LLM production reliability across 3 core pillars. First one is observability. Distributed tracing with span-level telemetry, real-time cost attribution, and complete prompt and completion capture across your entire LLM pipeline. You have full visibility into what your AI is doing, how long it takes, and what it costs at every step. Second one is evaluation. Automated continuous quality assessment using LLM-as-a-judge, semantic similarity, and other evaluation methodologies. Evaluation configs run asynchronously against every trace in production, and the offline dataset evaluation gives you a structured regression testing workflow to validate model and prompt changes before they reach users. Third one is Guardrails. Real-time content safety and PII detection policies enforced at the output layer, with zero downtime policy updates pushed instantly to connected services and a full audit trail for governance and compliance. Together, these capabilities give your organization the foundation to deploy AI applications with confidence, accountability, and control at production scale.